Welcome to Sophistic Online Documentation. In this video, we'll cover the fourth and final step of the general workflow for seismic nonlinear time history analysis. We'll demonstrate how to assess the performance of a structure's dynamic response using strain and rotation-based criteria. This step is performed using Graphic, one of our standard post-processing tools. First, we will revisit the criteria specified in the output of the plastic hinge task. For strain-based criteria, recall that we defined three performance levels for each materials, with fully operational level indicated by PL3, up to life safety level indicated by PL1. These criteria are also represented into the moment rotation workflow of the plastic hinge. Additionally, rotation-based criteria are available in the plastic hinge definition. P indicates the yielding capacity has been reached, U indicates the ultimate curvature, and X indicates failure. The plastic moment in this case is just below 6,000 kilonewton meter. We will use this criteria to assess the structural performance at a specific time step. Looking at the time history in the report from the nonlinear time history analysis, we can see that at around 3.1 seconds, some of the hinges are yielding and PL3 is reached in the element 10,023. We can also see this from the performance criteria status changes tables. Now let's switch to Graphic, where we will review first the strain-based performance levels. The left plot shows the performance levels in the concrete, while the right plot shows those into the reinforcement. At 3.1 seconds, we can see that the performance level 3 is reached in the bottom right plastic hinge. This corresponds to a strain of 10 per mil in the reinforcement in this location. For the concrete, none of the performance levels have been reached. We can also examine the rotation-based criteria by looking at the performance index at the same time step. It is clear that all of the hinges have reached their yielding moment. If we check the bending moment in the plastic hinge on the left, we can confirm that the plastic moment, just under 6,000 kilonewton, has been reached. Of course, we can change the time step in each of these plots, since the results are stored, allowing us to assess the time-dependent behavior of the structure. As of service spec number 2 of Sophistic 2026, we can now access plastic hinge results directly through the results viewer. By inserting an interactive lists and graphics task, we can create a tabular view of the plastic hinge results. As an example, we filter the bottom left hinge in beam number 10,023, and we select the stored load cases from the nonlinear time history analysis. The resulting table provides an overview of the plastic hinge behavior. It includes materials for strain-based performance categories, the moment and rotation at each time step, and their corresponding strain-based performance categories, and rotation-based performance indices. For the selected plastic hinge, we can see that at around 3.1 seconds, performance level 3 is reached, which is consistent with what we have previously deducted from the graphic results and the time histories. We can also see at this particular time step, the plastic hinge is yielding with a negative moment as denoted by minus P in the performance index. These results can be also used to create a diagram showing the hysteresis of the hinge. We copy the table and we insert a diagram where for the x-axis we use the rotation, for the y-axis we use the bending moment, and then we select beam element, selecting the same beam 10,023 where our plastic hinge is located. On the right side, we can observe the hysteresis forming between the rotation and the moment of this hinge. We can observe the plastic strain energy dissipation by examining the shape of the hysteresis. The rotation remains very small until the yielding moment is reached, just under 6,000 kN, after which we observe a plateau as the backbone of the plastic hinge, which behaves perfectly plastic. The cyclic behavior in this range follows the modified Takeda model rules discussed earlier in this tutorial. To understand how much of the dissipated energy occurs, for example, after reaching the reinforcement strain of 10 per mils, we can filter the results by the strain performance category PL3. This allows us to see which part of the hysteresis corresponds to the deformation beyond that performance level. With that, we conclude this tutorial on the seismic nonlinear time history analysis workflow. Thank you for your attention.